So when we're looking at projectile motion problems, we were just saying that our equation here has different parts. My starting point is going to be here on the end, this S of O. My velocity, how fast it's going at the start, is going to be here in the middle. That's my V value. And then this negative 16t squared at the start just stays the way it is. And wherever I end up is on the end here. Now, a couple of things to be reminded of. This S of t that we see here that's kind of funky is the same thing as just saying y equals. So if we go to put it in the calculator, this is basically just saying, oh, S of t, okay, that's y equals. The t values themselves is the same thing as just having x. So if I were to go type something in the calculator, I'd write it negative 16x squared and so on and so forth. So I can use the calculator to help me with this, and that's why I put up the little sign to grab yours out of there so you can kind of see how this works. And like it says here, t represents time, usually in seconds. It's usually what we're trying to find, but sometimes we're trying to find some other parts. So here's how this works. An object is launched directly upward at 64 feet per second. So I don't know if you had like a shotgun or just threw it straight. I don't know what it happens to be. At 64 feet per second. That's how fast it is to start. It's my velocity. Sometimes just marking those things down and writing it helps, sort of like when we're doing a vertex. When we keep saying the vertex is negative b over 2a. Working the same thing. From a platform 80 feet high. That's where I'm starting. Write the function for the height of this object at any given time. In other words, plug in the numbers you know so we have this equation. Okay, well, we just got done saying this part never changes, so we're going to write down the negative 16t squared first. And yes, when we do quizzes or tests, you'll always be given this form. It's not like we got to memorize it even. Plus my velocity times t. My velocity is 64, and I just put a t with it. And then plus wherever I'm starting, which in this case is 80. That would be my function, or my equation, for the height of this object at any given time. If I know how long it's been, I can plug that number in and tell you how far it's been going along. So when this says, when will the object reach its maximum height? What is this really asking me for? It's asking me, when it says when, it's asking me for the x value of the vertex, because let's think about this for a minute. Whenever we're graphing parabolas, okay, and I'll actually show you a picture in case you've forgotten here over time, and I'll move that back out of the way a minute so some of you that are typing can still do that. But if I don't remember, if the number in front of x squared is negative, my parabola is always going to open downward. So I can't even see the top of it way up here, but I can see, okay, that it's opening in a downward fashion. So for my purposes, knowing that it's opening down, its maximum height is going to be way up here at the max, at my vertex. And that's why we said that's what I'm looking for. So to find that value, and we just mentioned this a minute ago, so hopefully somebody's going to be able to help me out with this. If I'm looking for the x value of my vertex, what's that mini formula for finding it? Something to do with b and a. Somebody knows, I know you do. Take a shot. For those of you out there, you can tell I've got a quiet group here. Always just this quiet, silent. So in tune with what we're doing. Okay, so my vertex is negative b over 2a. So I start to look at this and I go, okay, my a value is negative 16. My B is 64. Okay, my C is 80. It's always good to know where those values are at in case I need them for something. So I go, okay, negative B, negative 64 over 2 times A. So let's see here. 2 times 16 is 32. Okay, so I get x equals 2. Now, in our case, that means it will take 2 seconds for this object to get to its maximum height. So then, when I'm asking for what is the maximum height, I know the x value. I just need to know the y. Now, some of you may have quickly started just typing 2 into all these things and gotten the answer. Perfectly legitimate way of doing this. So if I had any calculator, one of my options would be to start typing this in, but everywhere I see a t, I just replace it with a 2. Totally legit. Especially if you don't happen to have a graphing calculator handy. So I work that out and I go, okay, so y is 144, and this is all in feet, so that would be how high this goes. But what if there's an easier way to do it? Well, there is. If I type the expression into my calculator, okay, so just like here, except the x's replace the t's, and I get my graph. There's 2 ways I can do this. I can look at my chart and go to where x equals 2. Hey, check out y, 144, same thing. Okay, that works. So that's always an option. Here's the other option. I love this one because it even works with decimals. If I go back to the graph and I hit trace and then just punch in the x value that I want and hit enter, it'll do it for me. So like, let's say for instance, I'd have done my x value and it was like 1.5 and I'm like, ew, I don't want to do that. I could just hit trace and hit 1.5 and it would tell me what the y value is. So if you get a number that wouldn't be on your chart because it's not a whole number, this is an easy way to do it, but plugging it in always works too. So I like to give you options. Always good to have options. But sometimes some things are a little easier than others. So one more of this type and then we'll start bouncing around with some different things that can happen. All right, we got a baseball. Straight up in the air with an initial velocity of 29 feet per second. Okay, so velocity, got it. From a point exactly 6 feet off the ground. That's where I'm starting. And again, labeling these things is such a good idea. So write the function for the height of this object at any time. So we go back to that first expression we had, okay, that we're given, and we're just going to fill in numbers that we have again. So I look and I go, okay, negative 16t squared plus, I know my velocity, so 29t, and I know where I'm starting, plus 6. Got my equation, got my expression or my function. So then I start thinking, and I'm like, okay, when will this object return and hit the ground? Well, I think about it, and I'm like, okay, so if I throw something up, and then it comes back down. So what I want to know is, what is the x-intercept? If I were to punch this in my calculator, when's it going to get back down to where x equals 0? So again, I have options. I like options. To me, my best option is going to be the calculator this time, which is why, again, we do a lot of this in here. So I'm just going to tweak a couple of things in here. So I get my equation drawn back in because there really isn't an easy way to find the 0 otherwise. It gets kind of ugly. So I'm going to hit graph. Now, if, big if here, let me swing this over. Okay, remember when I'm looking for an x-intercept, my y value is 0 because, well, if it's on the x-axis, I didn't go up or down any. So my first inclination is always going to be to check the chart. If I check the chart and I can see where y equals 0, that x value tells me how long it takes. That's slick when that happens that way. But you're like, well, is that always going to happen where I'm going to be able to see y somewhere over here in my chart when I put this in? Not necessarily. So here can be my other trick of sorts using the calculator. And I'm going to jot the steps down for you in case you want to try this sometime. But it's always an option. So if I go back to the graph, I can see it crosses the x-axis right here. I see it, I want to know for sure what it is. So here's how this works. Just going to do a mini process here. We're going to hit second, and then trace. So second, trace, and I want the 0, which is number 2. So you can either, arrow down to it or just hit 2. So then this little blinky guy comes on there, this little cursor. So my second job is to get the little cursor guy as close as I can to the x-axis using my left and right buttons. Now, again, I want to get to this one. You're like, why not this one? Because that one looks like it might be in the negatives, and can something fall in negative time? Not really. So I'm going to hit my right arrow. He's going to disappear for a minute. That's okay. Keep watching this y value. It'll come back down in a minute. He'll show back up. Here he comes. You're like, well, I can't get real close. Like, that's the closest I can get right there. That's fine. Don't hit enter yet. We're going to left arrow 3 times and hit enter just to make sure. So we're there. 1, 2, 3. Hit enter. You're like, nothing happened. This little arrow or a line will show up, but we'll get back to that in a minute. I got one last step that's going to tell me the answer. I'm going to right arrow 6 times. You're like, why 6 times? Because what I'm doing is I'm trapping the intercept in. So 3 times gets me close. 3 more for a total of 6. And if I hit enter, it asks me for a guess. And I see the same thing. When y is 0, x is 2. You're like, that's a lot of work to go through. Why can't I just use the chart? Sometimes it may not be a whole number. So if it's not, that gives me an option to kind of work through. It didn't. Uh-oh. We're going to do another one here in a minute. Try it again when we do it this way, because there's a couple of things that can go haywire on us. Sometimes we may forget, we may hit an up or down arrow, and that can kind of throw us off too. So just something to consider a little bit. But okay, here come the actual problems. And again, this is where I'm going to work through the odds with you, and the evens I'm going to set you on your own for a little bit. So, all right, and we don't really need separate paper. We can fit everything in here. So fireworks are fired vertically into the air from the ground. From the ground. How high are we when we're on the ground? 0. Okay, that'll be important for us to know here in a minute. At an initial velocity of 80 feet per second. Okay. Find the highest point reached by the firework just as it explodes. Highest point. Y value of the vertex. And some of you may be thinking, okay, first of all, how am I going to know if it's x or y? And that'd be a really good question right now. Let me tell you. If I want to find the x value, if it has to do with time, how long is it going to take? How many seconds is it? Something like that. It's going to be my y value if I'm looking for something with distance or height. You know, how high was it before it went off? What's the value of it at this particular time? That's how I figure out the difference. But I'm typically going to be dealing with my vertex here. So I look and I go, okay, I'm going to have to do a little flipping back and forth here, because I'm still using that same formula we used on the last sheet, the negative 16t squared deal. So here's what we're going to do. negative 16t squared plus, I know my velocity, 80t. And if we're starting, because remember this endpoint's always where I start, I'm starting from the ground. So plus 0. So I look at this and I go, okay, I need the y value of the vertex. Well, Harty, can I get there directly? No. I need to find the x part first, then I'm going to substitute it in. You're like, all right, I guess. So there's my b. So the opposite of b, so negative 80 over 2 times a. So I start playing on the calculator with this. So I'm like, yeah, I don't know what 80 divided by 32 is off the top of my head. Well, guess what? I'm the teacher and I don't know either. So you get out of here. So negative 80 divided by negative 32. Ooh. It's not a whole number. Now, all is not lost. It just means I can't use the chart when I'm doing this. So again, I have choices. I can just take my equation right here and plug in the 2.5. And I think most of you are going to like that option better because that works on every calculator. I don't have to have a fancy schmancy one to do that. So my y equals 100 feet. Otherwise, you could type it, you can type it in the y equals part, and then hit trace, and you'd hit x equals 2.5. So if some of you like playing around with the calculator, you're like, yeah, it's kind of fun. I don't get to do this very often. So I would rather do it this way, and then say, okay, Harty, graph, and I'm going to hit trace. And what am I going to hit when I hit trace? I'm going to hit my x value, 2.5. Boom. Get my y value that way. Doesn't matter. Either way works perfectly peachy for our purposes. But I'm just letting you see you don't have to have a fancy schmancy calculator to make this work. Same idea as we hit 3. Pistol gets accidentally discharged vertically upward from a height of 3 feet above the ground. That's where I'm starting. If the bullet has an initial velocity of 200 feet per second, what's the maximum height it will reach? Y value of the vertex before it starts to fall back to the ground. You're like, so basically, the only thing that's changing about any of these problems is my vertex value, my velocity value, not quite sure where, I got vertex on the brain, and where I start from. Otherwise, I need that x value. And again, if you look when you're doing the x and you write down the negative b over 2a every time, trust me, it's going to get stuck into your brain. So even though I see it up there, I'm still going to write it and remind myself, negative b over 2a. Negative, the opposite of 200 over 2 times a. Calculator, do your magic. Get out of there. Negative 200. Try and stay out of my own way here. Okay. 6.25. But again, that's how long it's going to take. To get the actual value, me personally, I'm just going to type it in this way. Because by the time you go and you punch it into the calculator into y equals, and then you go back and you're looking for trace and hitting all those buttons, it's easier just to do this and be done. So y is 628 feet, is how high that bullet or BB or whatever it happens to be is going to go up before it starts coming back down. So again, I have to pay attention though, because it may not be the maximum height that I'm looking for every time. And that can be the kicker. To make some of you happy, You can go ahead and cross out number 6 because they didn't give me enough information to really get deep into this, and I don't want to make this go crazy here. Even though I think we probably could have fought our way through it. Okay, 5. Sam and Sarah have taken their math textbooks to the top of a 12-story building and look at the pool, which is 160, that should say feet, straight below them. Sam just lets go of his book. Why is he getting rid of his math book? While Sarah throws her book, down with an initial velocity of 48 feet per second. How many seconds does it take each book to hit the water? 2 problems going on at once. Okay, so for Sam, always going to be the same first part. If Sam just lets go of his book, what's its velocity? 0. There's no initial velocity. But we're starting at 160 feet. On the other hand, Sarah fires her book. She's really not having a good year in class. At 48 feet. Oh, Harty thought of one interesting thing here. Here's one thing we haven't talked about yet. Number 1, we fired it into the air. We fired it up. 3, we fired it upward. We're going up. This time, I'm taking it from the top and I'm throwing it down. If it's downward, down means I'm going to use a negative initial velocity. Bless you. So again, when I go to do this, am I looking for a max this time? No. How many seconds does it take for the book to hit the water? Find the x-intercept. Let's see if we get lucky. Hopefully we do. Okay, hit the water, hit the ground. Those are our big keys here. So all right, let's try this out for Sam. Negative 16x squared. And I really probably don't have to put in the 0x, but creature habit. Okay, so I see it looks like it's right there. Let's look at the chart, see if we get lucky. Dang. I don't see a 0 for y anywhere. Okay, that's not going to help me. But remember, what I can do here now is I can go back to my graph. Okay, I want that. We're going to have to do our little process again. So calculator people. Second, trace. I want the 0. So when you hit second trace, make sure you go to 0. Because if you hit any other ones, this isn't going to work. You're like, I don't even see the cursor, dude. Okay, watch your y. Okay, it's coming back down, so I'm going to keep going to the right. Because what's happening is he's up here somewhere. And he's coming, and he's coming. And whoa, there he is. You're like, dang. That's the only time I can even see him. Okay, so like we said on the front, once we see him, 3 clicks left. 1, 2, 3, hit enter. And then we go 3 to the right. There he is again. 3 more with an enter, enter. And we find out Sam's book took about a little over 3 seconds, because again, time is always my x value. Now for Sarah, same thing, except now this is minus 48x plus 160. Okay, the negative 16 stayed the same, the 160 did. So again, I got my graph. I see about where it is. I'm always going to check the table first. Okay, you're like, -5. Now think about that for a minute. It took her book -5 seconds to hit the ground. Yeah, that doesn't make sense. Let's see if we get it up. Oh, there's one on the positive side, though. And I'm done. So So if I'm using zeros, I gotta use the trick, or I use the chart and just see if it happens to work out that way. Almost there, because this actually is the last new one that we're gonna run into. So this will be the last one of these we play with, and then I'm gonna let you try on your own for a little bit. Okay, Maya shoots an arrow upward. The height of the arrow, t seconds later, is given by this equation. Okay, there it is. What was the initial velocity of the arrow when Maya shot it? Where do I find my velocity? Well, let's see. I find my velocity, it's whatever's in front of t. So I come back over. Oh, my initial velocity then would be 135. It's just that number. It's just that easy. I don't have to calculate anything. What's the maximum height by value? By the arrow, and the time, x value, at which this is reached. I need my vertex, people. Vertex. Okay, let's do this. X equals, what's the mini formula again? Negative b over 2a. So there's my b value. Negative b over 2a. So let's see. Negative 135 over negative 32. I think we're going into decimal land here again. All right, out of there. Negative 135 divided by negative 32. Hey. Okay, so it took about 4.22 seconds for this to happen. And again, remember, don't make this complicated on the y part. All I gotta do, there's my equation, just plug the x value back in. And that can be done with any old calculator. Don't be fancy. So it looks like about 287.8 feet was when this arrow reached its maximum height. And the only other thing I want you to do, complete the table to show the heights at the given times. Okay. I could just plug it in if I don't have a calculator. Totally legit. But if I have access to one, like I do right now, I'm going to go ahead. I'm going to type it in. I'm going to go to the chart. I'm going to start plugging numbers in. 236. 314. 264. And then the last question they ask me, find the average rate of change, slope, from t equals 4 to t equals 2. In other words, take the heights at those two, subtract them, take the 2 times, subtract them. I'll let the calculator help me out here. So 314 minus 236. Whoa, not 230 times, no. 78 over 2, or 39 feet per second. Okay. Again, let the calculator do all the work on this, and then I just got to remember, oh, it's like slope. It's y over x. It's rise over run. And then get my answers. So again, your job is to do numbers 2, 4, 8, and 10. 4 problems, people. I can put it back up here this way. Do 2, 4, 8, and 10. 4 problems. There's no reason to not do 4 problems. You've got like 15 minutes. I think you can do 4 problems in 15 minutes. So work on these. Tomorrow we'll get into review mode. We'll go from there.